want to give massive thanks to all of my supporting members and patrons. Thank you all so very much. Hello, good evening and welcome to everyone. Glad to see so many here already. I've got Kyle here in the live room with me, so we're all good to go. I shall bring him online now. Hello, Kyle.
Hello.
Yep, got sound. We got everything. This is good. How are you? And how's your family?
Doing well. Doing great.
Good, good. So, tonight we're going to have a bit of a debate about light being parallel. I'm presuming we're talking about the sun and stars, are we? Well, I'll tell you what, Kyle. Why don't you introduce yourself first? I should let you introduce yourself before we get stuck in.
All right. Well, I'm Kyle Adams. I run the Flat Earth Institute of Science.
And I've just realised
on my YouTube channel.
Sorry, I just realised you decided to come on cam, and I'm not set up to show you on cam.
Oh, that's all right.
Okay, so my apologies. Yeah, so you run the Flat Earth Institute of Science is the name, isn't it? That's your YouTube chat. Well, your YouTube channel was Kyle Adams, isn't it? But
yeah, it's Kyle Adams because I talk about more than just flat Earth. I like to talk about other things, and my whole idea with the Flat Earth Institute of Science is it's meant to expand beyond just me.
Okay. And you've been on this channel, I don't know how many times, 4 or 5 times maybe? Perhaps something like that, yeah. Well, tonight we've actually got a bit of a topic to perhaps get our teeth into, which might be interesting.
Yeah. This topic is actually one of the very first topics I ever produced a video on for my curriculum. So it's a good one.
Okay. Well, why don't I give you a few minutes to tell us all about it. I'll say the floor is yours, and I'll leave you to it for a minute, and then I'll respond, because I've got some stuff to show you as well. Okay. By the way, if you have any images or anything like that you want me to show, if you DM me, I can pop them up on the screen for you. If not, that's
sure
fine.
I could do that, but it'd end up taking more time to try and do that slowly. And I think I could say everything without it, and people still get what I'm talking about.
Okay, well, I'll shut up then, and I'll grab notes. Grab paper just in case I need to make any notes or anything you say, and I'll let you make your case. Go ahead, sir. The floor is yours.
Okay, so parallel light, or parallel rays of sunlight. That whole claim goes all the way back to the whole Eratosthenes story, and so that was one of the very first topics that I made. Was Eratosthenes was wrong, and I claimed that he was wrong because of all of his schematics were all based on this principle of light traveling in straight lines through the atmosphere down to Earth. And so we have this big problem over that, not just because of Eratosthenes, but that's also what we use to determine the distance to the sun or the moon and all these other celestial observations out there. People are building all of that math on straight parallel lines, and that's wrong. And I've got at least 4 different reasons why that claim is wrong. Number one, we know that the light from the sun is not parallel because it diverges. Even the globe model acknowledges the fact that the light diverges. That's part of how, just pointing at the globe model here, them confirming that the light diverges, is we have sunlight throughout the entire year. It's not just in one period of time throughout the year, but we've got sunlight in the middle of June as well as in the middle of December. That's because the light from the sun is going out in multiple directions. Okay, I hope you can agree with me there, Mr. Sensible.
Well, I'll let you carry on, and then I'll making notes. I'm making notes.
Okay, so yeah, we have light And that's just on the globe model. That's one instance of them agreeing with me that the light diverges. Okay. Another instance here that you should be able to agree with me here is that light dims over distance, because as the light gets farther and farther away from the source, the rays diverge out, and as the rays diverge out, their strength, I guess you could say, the luminosity is much weaker than it was at close range. And so when we just are to see a sunset in the evening, we can see, or even in the middle of the day, when the sun is directly overhead, as the sun gets farther away in the sky, or the light rays get farther away from the sun, they get dimmer. That's a very observable observation, and if you need pictures for that, I can provide pictures of that. So another major thing here that totally says that the light is not parallel is penumbra. If penumbra exists, the light can't be parallel. That's very observable. And if you ever pull out a diagram, even on the globe model, a diagram of penumbra, say during a solar eclipse, okay, all of the light rays have to converge in order for that penumbra, or they converge and then they diverge again. But yeah, all of that, the light ray has to be not parallel in order for that penumbra to exist. And my fourth point is refraction. We both agree that atmospheric Earth, my model and the globe model, we both agree that atmospheric refraction exists. And so long as there's atmospheric refraction, they can't be parallel because it's bending light. And so it has to be straight. So yeah, those are my major things. I hope you agree that celestial refraction exists. And with all of these 4 points, I really hope you can agree with me that the light from the sun is not parallel. There we go.
Do you have anything to say about the light from stars?
Light from the stars, it kind of follows the same thing with the sun. It's light, any light traveling through the atmosphere. So the sun, the moon, the stars, it's all going to be subject to celestial refraction, as the globe model claims. And yeah, so I don't even have to point out a whole lot on my model, which already acknowledges that, but I'm trying to point out a lot of things on your globe model that already acknowledge that the light from the sun is not parallel. And so if it's a claim that's made on both of our models, I think you should be able to really clearly agree with me that it's not parallel.
Okay. Is there anything else you want to mention or cover before I show my stuff, and then we can go into sort of back and forth about it?
Okay.
Is there anything else?
No, I think I covered each of my major points, and I'd like to know which of those that you have an issue with or anything like that. And if we have any issues that need resolving, then I can provide further evidence, and I've got some stuff to substantiate my claims further if you need me to do so.
Okay.
So I just kind of, yeah. So I'm kind of, this is the initial claim, and then I'll provide support when needed after that.
Okay, well, what I'll do then is I'll show the stuff I've got, and then then perhaps you can address any points I've made, and I'll address the points you've made. How does that sound? And then we can just go into back and forth. I mean, not being funny, I want to sort of hold your feet to the fire a bit tonight, rather than just a nice chat, a bit more debatey.
Okay.
But I know that you're not one for suddenly screaming and shouting and that sort of thing. So it can, even if we get involved in our disagreement, if we have a disagreement, I know it can still be civil, and that's fine.
Yeah, absolutely.
Okay, cool.
That's why I come back, because we can actually, it's a privilege to talk to you, and I really see that you accept it and see it as a privilege to talk to me too. So we have a mutual understanding that way, and that's what keeps me coming back to you.
Well, I'd say, Kyle, that I like to feel that I'll give as I'm treated, and you treat me decently without. I mean, as we know, there's some that will scream or shout or make racist, homophobic, or whatever attacks on someone, and I know that you don't do that.
When that starts to happen, then people lose focus
Yep.
of the privilege it is to be able to speak to someone. And
Okay.
so I don't want to abuse that privilege at all. So
Okay, right. Well, shall I show you my thoughts on this whole subject then?
go for it.
Okay, let me just get set up here. Right, I'm just moving a couple of windows around. So you should see the stuff. I don't think, Carl, just before I pull this up, I don't think there's anything that needs sound. No, there's one or a couple of bits where I might do some explaining, but there's nothing that requires you to hear sound, even though a couple of little bits are video. Okay, right. Let's transition this across so you can see that. You can see the sun there, can you now?
Yes.
Good. So you're seeing what everyone else is seeing. Okay, we got the sun, which is a sphere, a big sphere. I don't think there's any doubt about that. I hope there's no doubt about that. Now, the rays of light from the sun, rays of light in the sun go out in all directions, 360 degrees, all around the sphere. Again, I don't think that. Well, I should certainly hope that there better not be any disagreement about that. Basically, it shines equally from all directions. So if we had a close-up on one portion of the sun, the light rays are actually going out at each and every direction from every point in the sun. When we talk about the sun's rays coming towards the Earth, that doesn't mean that rays aren't flinging off from the same point all over the place. So any individual point on the sun will be shining out in every direction. So that whole, actually, will my mouse, I think my cursor's showing up there, yeah. So this whole area, even if that was the only point of the sun that was lit, this whole area you could see it from, because light photons are travelling outwards in every single possible direction. So if we took a look at the sun and the Earth, this is not to scale. None of these drawings are to scale. They can't be. We've got rays of light flying off the back side of the sun, downwards, upwards, every which way but loose. The only ones we see, though, are the ones that are roughly travelling along in this direction until they hit the Earth. So that long cone shape or triangle shape, that's the path of light that hits us. Light is going everywhere else as well, but we don't see it. So from there, we can see the top of the sun, we can see the bottom of the sun, we see the whole sun. So if we took a close-up view, there's the sun and the Earth, again, very, very much not to scale, either in distance or sizes. We can show the boundary lines. Any rays of light from the top and the bottom that travel towards the Earth in this direction are the ones we can see. Any others, even if they just miss us a bit, we do not see. They'll just go past us and on into infinity. So that's all very well. Those rays of light from the top and the bottom of the sun are obviously not parallel. If you had two rays from the 3 o'clock position coming straight towards the Earth, those ones could be parallel, but the top and the bottom are not parallel. So if we move the Earth further away, again, we got the same effect. We got the light rays from the top and the bottom of the sun hitting the top and the bottom of the Earth, not parallel, but they make a less acute angle at the Earth. They're a little bit straighter. And if you, that's a bad word. All the light rays are travelling straight until they hit the atmosphere, when they can get refracted a bit. But while they're in space, they're travelling straight. So if we zoom out further, again, the top of the sun to the Earth, the bottom of the sun to the Earth, the light rays are travelling. It's looking a lot less like a triangle. They seem to be getting a bit more parallel. And again, you zoom out again, definitely not to scale, but you can see these are getting closer and closer to parallel. Oh, I'll come back to that one. Closer and closer to parallel. So when you actually get to scale, I'm not sure how far that Earth would be. It would certainly be smaller, but how far that Earth would be from the sun if the sun's this scale, but it's going to be quite a distance. Those light rays are as near as damn it then parallel. Now the sun looks to us as though it's got an angular size of about half a degree, just over half a degree, which means light rays from the top and the bottom are well, looking from Earth, that the path diverges towards the top and the bottom of the sun by half a degree. So pretty
When they
damn
come closer together, that's converging.
Yes, thank you for yes, I couldn't think of the word then. Yeah, so basically there is a convergence of half a degree. That's what we're talking about. So we're pretty close to parallel. Now most of the rays will be within that boundary of the top and the bottom. They could be straight on the middle of the face. So they're even less divergent. Basically the divergence is negligible. If I show you this next slide, I'm going to ask you, what do you see there, Kyle? And I suppose it's a trick question, but I'm not, it's not a gotcha. What do you see at face value?
In that picture right there, they look pretty close to parallel.
Yeah, it looks like you've got a pair of parallel lines at the top and a pair of parallel lines at the bottom. What we actually have...
so close to parallel, it's really hard to tell that they're not parallel.
Yeah, well, I drew the very top line. I then copied it, dragged it down, and pasted it. So those two lines, the top pair of lines, are parallel to each other. I then pasted it again here, dragged it down, pasted it again, and then moved this bottom, to be honest, I can't remember, either in or out by 1 pixel. It's so close to parallel as makes no difference. That's the sort of effect we're getting, because the sun is not a point source of light, so it is not going to be parallel to an infinite number of decimal places. There can be a very, very slight convergence, but to all intents and purposes it's striking us parallel. Now you mentioned what was it? You mentioned Eratosthenes. With Eratosthenes, there would be slight error due to that slight divergence, but in the scale of things and the accuracy he was working to, it made no difference. He could treat those rays of light, treat them as parallel. Light does travel straight in a vacuum, unless it's passing by a supermassive object like a galaxy, in which case it can be, well, actually even the sun, it can be bent slightly, but to all intents and purposes light travels straight in a vacuum. When you get to the atmosphere, there can be, of course, some refraction, which is the greater amount of atmosphere you're looking through, so that's down towards the horizon. I did wonder if you were going to make a comment about something like this, Kyle. This picture, this sort of thing. Does this have any bearing on your discussion, your position?
Yeah, I can look at that picture immediately and give you evidence that the light in that picture is not parallel. And I'm going to point to the edge of the shadow. I can see Penumbra on the edge of that shadow. Do you agree that that Penumbra exists because the light is not perfectly parallel?
Okay, I will come back to Penumbra in a moment, because I have something to say about penumbras, okay, if I may. Okay, so you're saying not parallel because of the Penumbra. Would you make any claims with regard to those visible rays of light?
I just pointed out the Penumbra.
Just the Penumbra, okay. Okay. It's just that I'm sure you must have seen that some people, like for instance Raichi 00000, have said things like, well, because those rays of light are going in all directions, optically that's how it looks, visually that's how it looks, because of that they're not parallel. And the fact that the trees' shadows appear to be going towards let's say the 5 o'clock position over here and the 7 o'clock position over here, therefore it's not parallel. You wouldn't agree with that then?
I know what perspective is. I've studied art for a long time, so I don't really make my claim when them not being parallel, unless you're looking at this picture on a 2-dimensional plane.
Okay. Well, Carl, I have to say I'm glad I'm glad. I was fearful that you would say the same as Rachie and say, yeah, those rays of light are diverging around that from that center point. So I'm
If
glad.
this is a two-dimensional plane, they would. But if
Yes,
this is
yeah. But we're talking about an
plane,
image of a
yeah.
three-dimensional
That's not
view.
my argument. And so,
No.
yeah, that's why
I'm glad. That's
focus on
fine.
the
That is
Penumbra.
fine. I won't hold that against you or hold. I won't hold that against you. I'm glad that that's not an argument you're making, because the next thing I was going to show was that because those rails are vertically parallel to each other, but the shadows apparently are diverging. They're not really. It just depends on your view. As you said, it's perspective, but that's not the argument you're making. So that is.
I like this example of the penumbra again on the shadows. It's a very clear, obvious statement or observation that says the light from the sun is not parallel.
Yeah. Sorry, 1 second. I just want to check something. Okay. Right. Well, like I said, Carl, I'm genuinely glad about that. So, okay, let's go to Umbra and Penumbra, because I did a video about that some time ago.
Yes, I'm aware of that.
Oh, so you've seen this video before?
Yes, I have.
Okay, because that was, what was the guy's name? Gosh, I can't think of his name now. He was saying that a penumbra couldn't be larger than the original object. And for those who haven't seen this before, I'll just sort of scoot through it. So I had a sheet of paper with a cardboard disc, which I drew around a cardboard disc, basically, left a circle. I then moved... Actually, let's just play it. I moved the disc further and further away, casting a shadow as accurately as I could in the middle of the circle. I then took several screenshots of the video, and with editing, I took out. Sorry, I'm just trying to find the exact point. There we go. I took out the white of the page, so all you would see is everything that was left. I want to find the exact point. That was next image. Right, so this was the final paused image. Took out the white, and then when I deleted it, I'm going to go right to the end. I'm sure it shows. Oh, that's it, actually. Yes, I've deleted the white, leaving the black, showing the penumbra larger than the drawn circle. So I had that ready. So I suppose in a way, it's good that you brought up penumbras. Excuse me. Yes, you get a penumbra because of the convergence and divergence of rays. So we can agree on that, Kyle.
All right, common ground. I like that. That's good.
I'm going to have to ban that term, I think, Kyle. Ban the term common ground. Okay.
Can it? Why?
It's okay. It's okay. Don't worry. Yeah, don't worry. Yeah, so,
Okay,
there is penumbra because of that divergence. But in this instance, we're talking about a small object, and I've, in effect, taken it as far away from that paper as I could. I was stood quite a distance away up on a chair to make the penumbra as large as possible. And you're correct. If you look at, if I go right in, oh, this is funny. It doesn't seem. Oh, there. The shadow looks pretty sharp. I mean, it's not perfectly sharp, but pretty sharp. But as you get further away, it blurs as the penumbra gets more and more noticeable, and the umbra, the dark bit, appears to get smaller. So I guess there's no disagreements there then, Carl.
So yeah, you're telling me that you agree with me that the existence of penumbra demonstrates the fact that the light from the sun is not parallel, correct?
Well, the light from the sun is within half a degree. That's the most divergent, convergent it can be, because that's light from the top and the bottom of the sun. So I'll just switch that back off for now. Yeah, so light from the top and the bottom of the sun. That's the greatest angle you can have, is half a degree. Any light coming from any other portion of the sun is going to be more parallel, closer to parallel. Perhaps that's a better term.
Closer to parallel. Okay,
Closer to
yeah,
parallel.
So,
Some of it will be
Okay.
absolutely parallel, but at worst, it's half a degree.
well, we see a gradient, and that means not all of the light is equal. And
How do you mean?
that makes sense. See the gradient in the penumbra, it gets darker as it gets closer to the center when it gets closer to the umbra, right? And so the only reason why we have a gradient is because it's
What it
there's
is, the reason you
less
get
light reaching the umbra and there's more light reaching
the reason you have a gradient is that more of the sun is peeping around the edge of the cardboard disc, or in the case of an eclipse, when you're in totality and the sun is totally hidden, you're in a totally shaded area. As soon as a fraction of the sun peeps around, you're getting some light, so that negates some of the shadow. And the more of the sun that is showing, the brighter that is. That's your gradient, because you can see more of the light.
All right. So, do you agree with me that almost parallel light should produce next to non-existent umbra and penumbra?
Well, we have a light that's at most half a degree off of parallel, and that's the amount of umbra and penumbra you get. The closer the two objects are together, like with my cardboard disc, the closer it is to the paper. Or if you had a hand over, do you know what I mean, on a brick wall or something, the closer your hand is, the sharper your shadow will look. The further away it is, the more you start to see that blur.
Okay. So, you're saying you agree with me or disagree with me there?
Well, restate what you said then to make sure.
Okay. Next to parallel light, okay, should produce next to non-existent umbra and penumbra.
The closer it is to completely parallel all over, then you would get no umbra penumbra. If you had a light source the exact same size as the blocking object, then its shadow would trail behind it in a cylinder, wouldn't it? If the light is bigger, yes, that shadow will get smaller in a cone. If the light source is smaller than the blocking object, the shadow will get larger in a cone.
So the closer we get to being perfectly parallel, the smaller that penumbra is going to be. And so
yes,
if it's
yes,
perfectly parallel, it's non-existent. So it sounds like we agree. We agree on that.
Right. Well, you did make a few points, and I said I'd cover them. I'm not trying to avoid anything. We've mentioned the penumbra. Right. You said your first point was sunlight is not parallel; it diverges. We have sunlight all year. I want you to explain that a bit, if you can.
You drew it out in your diagram. You showed the light coming from the sun. You drew the sun as this perfect sphere with light coming out in all directions, right?
Yes.
Right. And that was you demonstrating that your model claims that the light from the sun is not parallel.
I'm claiming that the light from the sun is within half a degree of parallel. Within
You're right next
half
to
a
the
degree.
sun? You
Oh,
just
right next.
your sun
Sorry,
up
do you want me
there.
to bring that image back up? I think I know which one you mean. Let me just go back. I think. Do you mean this one?
No, it's talking about the other one with the lines coming out in all directions. But
Okay.
That one also.
That one there.
That one works as well as
that one.
the other one. One works as well. I was talking about the other one with the black lines going out.
Oh, that
there
one.
we go.
Okay.
Yeah.
Right. Sorry. Go
Yeah.
and say what you were going to say about it.
Yeah, this was just your model agreeing with me that the light from the sun is not parallel. And so in order for you to continue your argument, you have to say, okay, well, we're not talking about all of the light from the sun. We're only talking about a very specific amount of light from the sun. So this is kind of like moving the goalpost.
No. I see what you're right. I see what you're saying, and I'm not moving the goalposts. We're talking about the light that we see. Excuse me again. The light that reaches the Earth, because it's a three-dimensional spherical light source. Light goes out equally in all directions. But the only light we see is the light which hits our eyes, the light which reaches us. The light which reaches us is all but parallel.
I guess no goalposts were actually established in this instance because you never opened up with an opening claim that we were either fighting for or against. Well, all you had was the term parallel light, and then we just made a statement on that. And so I can't accuse you of moving goalposts on that.
Right,
so,
right. Well, this diagram I'm showing here, if I was claiming that all the light came from the sun to the earth like that, and there was no light going anywhere else, that would be a claim that quite frankly is ridiculous, because what about the far side of the sun? No, it's just that the light within that cone is the light that we can see, because it's only light rays that are within that cone that reach us. Any others, well, we don't see. If you're up in up on a visiting spaceship touring through our solar system, you would see other light rays, the ones that don't hit us.
Okay, so I can agree with you that some of the light from the sun is parallel. Some of it, but not all of it. The vast majority of the light from the sun is not parallel. Would you agree with me?
Well, that...
As you said,
I don't know if that's being... I don't wish to be rude, but I don't know if that's being a bit mealy-mouthed, because, of course, that Earth rotates...
Mealy-mouthed? I'm not familiar with that term.
Okay, we'll forget. Disingenuous?
Disingenuous, okay.
I'm not... Let me make my point. That little green Earth is there at the 3 o'clock position against the sun, if we're treating this like a three-dimensional. But in 6 months' time, it will be on the other side of the sun. Yep. So light rays headed in that direction are the ones we see. Of course, the sun is rotating all the time, so we're seeing a different face of the sun, but the light is continuing in all directions at all times. So I'm not really sure what you're saying. So the light, I mean, this one is grossly out of scale. Let's go to one that's a bit let's say that one. It's a little bit closer to realistic. So we only see a tiny portion. In fact, as the sun is shining in 360 degrees, and its face is apparently half a degree to us, we see half a degree's worth of the light that is coming out of the sun.
We see very small amount of all of the light that the sun actually casts.
Yes, because it's
out of that tiny little fraction of light that we see, compared to all of the sun, I can agree with you that only a small amount of it is actually parallel, but the vast majority of all of the sunlight coming out of the sun is not parallel.
But if I go back to that one again,
so the vast majority is not parallel.
Well, again, our Earth, let's stick to the same position. Our Earth is over in a 3 o'clock position, so the light travelling sort of in that direction is the light we see, but the light is travelling over at the 10 o'clock position. So if there was another planet over there, it would be receiving parallel light. Do you see what I'm saying? Of course, in totality, the light that's shining the light that's shining from all directions is not okay. Yeah, that's not parallel, but there's nothing special about that. It's the lights that you see.
Degrees right there.
I'm sorry, say again.
Oh, you said you've got the light from the sun going east, and then you got another one going, what's that, northwest? And so just on your diagram there, I'm like, those two rays are not parallel.
No, they're not parallel with each other, but if you were over there at the same distance that the Earth is, the rays that you're receiving, again, would be within half a degree of each other, all but parallel. The only rays you care about are the ones you see. I'm not claiming that every ray of light coming from the sun is parallel with every other ray of light. Does that make it clearer?
Okay, so you're not claiming that all of the sunlight from the sun is parallel?
No, I'm claiming that all the sunlight that we see, all the sunlight that hits the Earth, is virtually parallel. It's within half a degree.
Okay. So
Okay.
it's
And as for
virtually parallel.
stars,
It's not perfectly parallel. It's
well, some of
yeah,
it is. Some of it is. Some of
yeah,
it
and I
is.
agree with you
But
there.
but
So
but
I
not
said
all
that
of it.
some of the light is, but the vast majority of it is not. It's my whole statement.
Yeah. I've just spotted as someone because I'm not keeping an eye on the chat. Real Signal says all rays are very close to parallel on average, less than half a degree. That's right.
Uh-huh.
So the worst it can be is half a degree convergence. So that's pretty damn close. And as for stars, I mean, stars could be smaller than the sun. They could be. I mean, the sun is not a big star. Sorry, I'm just switching that back off again. Some stars are hugely bigger than the sun. The problem is the distance. I showed that diagram with the Earth being further and further away diagrammatically, so the lines from the top and the bottom of the sun were looking closer and closer to parallel. By the time you talk about stellar distances, that although the source could be huge compared to the Earth, the top and the bottom drawn as lines to the Earth, as I was drawing, are so close to parallel you probably couldn't even measure it. Arc seconds out, or even less than that, minuscule. Again, so close to parallel as makes no difference.
Okay. So are you aware of Neil Tyson's sunset illusion, that where he comes out and talks about celestial refraction, about how Neil Tyson describes how on the globe model the sun sets later because of refraction.
Is that deGrasse Tyson?
Yeah, Neil deGrasse Tyson.
Yes, the sun appears slightly sooner than it really is over the horizon. It disappears slightly later than when it really is behind the horizon, because refraction. Yeah, that's a known.
So this
known
refraction
thing.
breaks parallel lines, and would you say that refraction breaks it more above and beyond that normal?
Parallel lines can be bent. You think of rail lines; they can go round curves. We're talking about I don't know, a refraction of a degree or something.
We're talking about all of the light that reaches the Earth, and so yeah.
No. It's not all the light that reaches the Earth. When the sun is shining, it's shining and lighting up half or approximately half of the sphere. But you're stood in one place, and as you cross the terminator and you're approaching sunset, then for you, the light rays that are travelling to you personally, they're the ones that are going through a greater and greater amount of atmosphere as the sun drops. And so the refraction of the light rays that reach your eyes is greater. For someone else at the equator, it's midday, the sun's straight overhead, refraction is zero, basically. It depends where you are.
We've got refraction over here, and we have no refraction over here, according to your model. Right?
Yes.
And so that's going to not be parallel. If it's bending over here and is going next to straight over here, that's not parallel. And I don't think you claim that it's only 5 degrees from being off of parallel, do you?
No, I didn't say 5 degrees. I said
0.5 degrees.
0.5
right?
degrees, yes. Well, if you said, just for discussion purposes, Kyle, let's assume that every ray that hits the Earth would be absolutely parallel if there was no atmosphere, okay? But then we pop an atmosphere in. Well, if you're on the equator with the sun exactly overhead, your refraction will be nil. If you're right at the terminator line, so you've got a sunrise or a sunset, in effect the end of the light rays travelled all the way from the sun going dead straight, and then it's got a slight curve just at the end. It's bending it slightly.
Yes, it's going to bend it, and so therefore it's not parallel.
Well, if there were two rays next to each other, they're parallel with each other. We're talking about minuscule amounts, minuscule, and it's a well-known thing. That's why, for instance, I daren't almost use the word sextant, but you wouldn't take sextant readings of stars, etc., when they're too close to the horizon, because refraction has a greater and greater effect. I think up to about 15 degrees of the horizon, if you're going closer to the horizon, refraction gets more and more of a problem. But yes, as the sun sets, the refracted light, it's bent. So if you imagine a curve going into your eye, you're looking up on the top of the curve, so the object you see appears to still be in the sky, where in fact it's just gone over the horizon.
That's their claim, and I've built my
More than a
entire
claim.
series. It's the globe model claim here about the light from the sun, and going kind of trying to articulate my words the best I can here. Fish tank laser experiments are all built around that claim, is what I'm trying to say. And that's the rivaling claim. We've got two rivaling claims about what happens with light on the atmosphere and the sun and boats on the horizon, all these things. And so I've got the picture in my mind, but I don't have the words to quite articulate.
Right. I've seen the experiments shining lasers through fish tanks with sugared water in it. I think it's usually sugared water, isn't it? And yeah, that gives you a density gradient, so that will bend light. That's how we get refraction. It's temperature and density gradients. You should have a look at Walter Bislin's site or page, because he's got an app and you can change things like the temperature gradient and see how it affects what you can see, and it's extremely accurate. I was looking. Sorry, go on, carry on.
How do you judge on how accurate that is? Because last I checked, the atmosphere isn't all one constant. It's not consistent.
No,
that's what
right.
I'm trying to say. And so, in order to have the math like that always lines up, it's got to require really consistent atmosphere.
Right. I'm actually
quite match up with
hold
reality.
on.
I can't quite call it accurate unless the atmosphere was consistent like that.
Right. I'm just going to try and do this on the fly, because it's something that I was looking at earlier for something else. Let me just see if I can do some degree pokery, and hopefully I'm looking at the right page and actually show you something that is, to be honest, it's not that one. Let's try again. It's actually quite stunning. You know the whole thing about the black swan. I assume you've heard all about that.
Yes.
Yeah. Well, this is. Let me see. Am I looking at the right page? Okay. Let me switch this on. This is Walter Bislin's page. Let me see if I can. Oh, it's not really going to let me resize it. Now, those are the black swan photos. So on the right is the normal photo. That's what you would normally see, with the nearest platform sort of just going behind the horizon. The further
you say that's what you normally
yes,
see?
yes.
What makes you say that?
Well,
I've only seen. How many pictures do you have of that to actually verify the claim that it's what you normally see?
Okay, right. Well, let me just say. So that is what is normally seen. The other photo on the left is the black swan photo. The reason that is, I can say that is what is normally seen, is the guy who made the video, BLMS, BS, whatever is in 69, he actually put in the video, on rare occasions, the atmosphere is just right, so you can see that image on the left. So he has said that's a rare thing. But that's not what I'm covering, because we're not covering the black swan itself tonight. But so those are the two images. Forget which is rare and which is not. Those are the two images. Now, what Walter Bislin's simulator did was he took two photos of the two platforms, close-up photos, and then he pumped them in to his simulator, and he got this. Now, those are both calculated. The one on the right is calculated with standard refraction. Actually, I realise you can't see it all. I don't know. Let me just see if I can resize this page a bit, because I found this quite stunning. Okay, if I move that across a bit. Right, so you should, I hope, I don't know if, has it come through? I don't know if it's not showing in Discord. Yes, it is. Yeah, so the image on the left is the distorted furthest platform, but this is calculated. This is not a photo of it with that bendy crane. This is taking a straight photo like the one on the right. You can see the crane there, applying refraction calculations, and he gets that bendy crane just like the photo from the Black Swan with the bendy crane. That's incredible accuracy with his simulator. He ends up with the same bendy crane. So I thoroughly recommend Walter Bislin's page because I found it absolutely stunning that he can apply atmospheric gradients.
You claim that this shows the curvature of the Earth?
I'm not... right.
In the image on the right here?
The image on the right? The image
on the right, do you claim that it shows the curvature of the Earth?
That shows a horizon which is caused by the curvature of the Earth. But Kyle...
this seems to be going contrary to what Neil Tyson said when he said that you can't see curvature from 2 millimeters above this beach ball. That whole statement there.
Right. No. Okay, let's address that quickly. First of all, the horizon is caused by the curve of the Earth looking away from you. What Neil is talking about is saying you can't see the curve left-right. The curve of the horizon.
You're talking about the x-axis and the z-axis, right?
Yes. So from left and right,
that you can't see any curve on the x-axis, but you can see curvature on the z-axis. Now, my whole thing here for you is, why wouldn't it be equal? If we can't see any curvature over X amount of miles on the x-axis, why should there be curvature in the same amount of distance on the z-axis? Should be the same on both ways.
Well, it is the same, but on the z, sorry, I can't get used to saying z, but on the z-axis, as soon as there is some curve, everything else behind is hidden, and the further away from you is, the more of it is hidden. Looking left and right, the only curve you can see is drop towards each side. Now, on a little picture like that, you're not going to see it. If you had a very wide picture, then you still won't see it with the naked eye. It's tiny, but you must have seen that photo, I think it's on MC Toon's website, with a guy who had some straight metal edges and took a photo.
Yes, I did a video on that.
Okay, and then he compressed it left-right. You could see that there was curvature. So that's the left-right curvature that Neil deGrasse Tyson...
We talked about
Hold on. That was the left-right curvature that Neil deGrasse Tyson was saying when he said you're not going to see it. Because you're not going to see it with the naked eye. It's too small.
We talked about that one, and I got the whole video of disconfirming evidence about that. So if you can't see any curvature on the x-axis, you shouldn't be able to see any curvature on the z-axis if they're the same. That's unless we live on a cylinder.
Yes, but looking away towards the horizon, you're not seeing curve. You're seeing C, 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 no more C. Do you see what I'm saying?
You just barely said that we're not seeing any curve on the horizon, so I've got to agree with you there.
I am saying that if I'm looking straight ahead, okay, there is curve, but I'm not seeing curve. I'm seeing ocean, 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 and suddenly, because that curve is cumulative, I'm suddenly seeing no more ocean. Now, with refraction, light from beyond that point can be bent into my eyes. So on those days, that horizon, the apparent horizon, will be pushed further away. You'll see slightly more, which is the Black Swan, because that's a day with excessive refraction, so you can see a long distance past the regular standard refracted apparent horizon distance, and it lifts up more and more ocean, and it lifts up whichever it was, platform hill house or whatever it was called, so that you can see it or see more of it.
So one of the key points that I've really pointed out in my fish tank laser experiments is about the control image, and how when I did my images with the fish tank experiment, I had to get a picture of the non-refracted image, and then I compared that with the refracted image. And when I compared that with the refracted image, the entire boat out in the horizon, it all appeared higher than it was because of the downward refraction. But at the same time, the boat also appeared to be sinking because of the downward refraction. And so, what I've never seen anyone do with this black swan images that you're talking about is compare it with the control image. And so, what I did later on in the fish tank laser experiments is I compared it to the Skunk Bay observation, where we can actually watch the entire horizon move up and down. And we saw that as we watched the entire horizon move up and down, and compared which one had the more compression, when it was up higher or when it was down lower. And the results were quite telling. I'll just say that.
Right.
And so what I'm saying is, with these black swan images, all you've got are two images, and then you're just taking these two different images and are putting them side by side to show that the horizon being at the exact same level. And so if you're going to say refraction, I'm going to ask for some kind of time-lapse photo, because I can take any images I want, and so long as my camera is not in a fixed position, I can just tilt that camera down, or I can tilt it upward, and I can't tell
well, to be fair
where
to
the horizon line is.
Yeah,
Does that make sense?
To be fair to the black swan image, it's not the actual height of the horizon in the image, because, as you said, the camera could be tilted up, could be tilted down. If you took the
there's a lot of variables in that image that I'm pointing out.
No, yes, but Carl, if I took a photo of the horizon at the beach and then tilted the camera down a bit and took another photo of that same horizon a few minutes apart, refraction has not changed. If I literally just uploaded those two photos, the line of the horizon will appear higher in the other. That's not a fair...
I agree.
Yeah,
I agree.
But with the difference is, with the those two black swan photos, the difference is that on one of the photos you could see more. You could see more. In fact, you could see the entire second platform, which you couldn't see in the other. You can't do that just by tilting the camera up or down or holding it above your head or anything like that. The only difference is
where
that
the horizon meets. My point is talking about determining which one is more refracted than the other one. Does that make sense?
Well, I think it... I don't know if I didn't close that page, did I? I hope I didn't. I don't think...
You can't just look at it and say, oh, this one's more distorted, therefore it's more refracted. And
well, agree with that. Yeah, you can.
There's some heat haze going on in there, but I can look at a fish in a fish tank and it doesn't look distorted. So distortion doesn't automatically mean that it's more refracted.
You certainly can tell. So I'm trying to resize this so that people can see both of these photos. Right. Yes, you can see them both there. Now, if you can't see that photo on the left is hideously distorted, you need new eyes, pal, because the crane...
I'm saying that distortion is not the key indicator of refraction, because an object can be refracted without being distorted.
Can an object with a crane that you could look at close and has dead straight steel beams, can it look like that crane in the image on the left without distortion? It's the very definition of distortion. It's twisted, it's out of shape. Look at the size of
distortion tells the presence of refraction. I agree with you there.
Okay.
But an object can still be refracted without showing any signs of distortion. And my classic example is showing an image of a fish in a fish tank and how the light ends up getting magnified. It ends up looking bigger than it actually is.
Yes, it does look slightly bigger.
It doesn't look distorted at all. It doesn't look distorted. It just looks like a normal fish.
Because I guess...
So there's different kinds of refraction, and this kind right here that where it's all looking weird and wavy, that can be called heat haze. Heat haze
It's
distorts all
it's
of
not heat
the
haze
light.
because it's. I mean, you'd have to look at BLMS's video. Excuse me, but it's not heat haze because it's just not. I don't know what else to say, Carl. It's not heat haze.
There's different
if it was
kinds
heat
of
haze, it would be
atmospheric
affecting the other
refractions,
one
no
as
point.
well. And if you've seen the video, it's not waving like seeing a car in the distance if you're looking really low over a really hot tarmac. That sort of heat haze with it all rippling like water.
And this is where it'd be really nice to have time-lapse footage of this particular occurrence, so we could see it throughout the day, and so we can know more details about it. Because this by itself is not really enough information to make heads or tails on it exactly.
Well, you could have a look at BLMS's video if you like, because his video consists of two parts. It's one showing the two platforms, the nearer one with part of its legs missing, the further one only the top half of the platform showing. Then he shows a slide saying, but on certain days, on rare occasions, the atmospheric conditions are just right so you can see more. Then he shows this black swan. So that
which
is
one
not.
is his control image? Which one is his control image?
Well, he's not. He's just showing two statuses, and since he has admitted that the first one is normal, as in that's what you see. I don't know. Say
Okay, so it's
80%
just a
of
kind
the time.
A trust me, bro, kind of statement here. This is normal because I said so.
Well, if since he is a flat earther and was trying to show that there's no curve, you would think if he was going to lie, he would say most of the time it looks like this, but only on some occasions is it partly hidden. No, he even admitted, he was honest enough to admit that nearly all the time that furthest platform is half hidden.
Yeah, I went through this with Chicago skyline footage, and so he made a claim that about Chicago, and so I went and actually investigated it and found out Chicago is normally visible from that distance, normally visible. And so because the guy who took the photo, I can't remember his name off the top of my head, I actually went and looked. He's got a ton of different photos of Chicago throughout the entire year, and I found out that it was quite shocking to me, and so I went and documented that.
Well, here you go.
I can't quite.
Here you go, Kyle. That's what the platform normally looks
like.
like.
Close.
Yeah, up close. So there's no doubt that's not distorted. Look at that crane. Yes, I mean, obviously it gets narrower towards the end, but the top and the bottom of it are straight as a die.
Okay.
That shows that other image was thoroughly distorted. It's not a wibbly wobbly wavy crane. It's straight.
Yes.
So
I agree.
I think you could use that as a control, since it looks like you're a couple hundred feet away from it.
Do you think a control image should be taken from the same position as on the beach?
Well, it's control, as in that's what it actually looks like. If you went on board and put your hands on it, that crane is straight. So you can't get more
I think
control.
it's really important to take the control image in the same position as the non-control image, the experimental image. So we have to.
Well, if you look at any
same spot in the exact same position, yeah, and then kind of watch as it changes throughout the day. That's what I'm looking for.
that
when it
is
comes to a time-lapse footage.
Hold on. There's two aspects here. We've got the fact that in reality, if you went up and landed on platform or boarded that platform, you would see that is what the platform looks like. You would see that those cranes are straight. Now, what you're saying about
I'm not claiming that they're not. I'm not claiming that they're actually curved.
Okay,
or anything like that.
so therefore, which of these? Sorry, I've got so many windows open now. Which of these two views of the crane is likely to be the least distorted? The one with the straight crane, as you can see close up, or the one with the bendy crane? It's got to be the one with the.
I agree.
It's got to be the one with the straight.
The bendy crane has got more distortion in it. Okay, but that doesn't mean the picture on the right has no refraction in it whatsoever.
No, of course. Well, look, put your hand in front of your face. if you're looking at it, there is refraction. It's just that it's such a minuscule amount that you know it's
probably
probably
my face proves that there's refraction in the image.
anything you can see. Anything you can see. Look across the room. There is refraction. What you're looking at, your TV or whatever, there is refraction, but it's as near as damn it's zero. I mean, you're looking through an atmosphere. By definition, there has to be refraction. But it's going to be a minuscule amount just across, looking at your hand at arm's length or looking across the room. In this case, we're looking across several miles with an atmospheric temperature gradient over cold water. And so the light gets bent to buggery.
Okay, and so this is where I kind of went to the Skunk Bay example. The Skunk Bay example, I think, was superior to that one because I got the footage in a fixed position, time-lapse footage where I'm actually watching the horizon move up and down. I noticed that I could see farther. I could see a lot farther in the less distorted image than I could in the more distorted image.
Well, so this is your video, is it? When you said Skunk Bay, I don't know the name Skunk Bay. I do recall seeing a video where someone's looking across a bay and, as you say, it's time lapse, and you can see whatever it was, the other side lifting, stretching, almost like waves washing up and down, wasn't it? So was that your video, or is there another one?
I went and shared it from someone else. I shared it. So this is the fish tank laser experiment part 4, and I shared the Skunk Bay footage that someone else took, and it was time-lapse footage of the Skunk Bay thing, which was nice because the camera was in a fixed position the entire time, and that was really important. And I compared the horizon line throughout the day and exactly how far I could see throughout the day.
Right, I'm just having a quick look on YouTube. Skunk. I think I found it. That's good. 1 second. Oh. So I will have to get rid of sound. Thanks to the wonders.
No, it wasn't part 4. It was part 3.
No. I think I found that original Skunk Bay footage. I think it looks like it. Let me just load up here and mute it because obviously
a screenshot.
Right, switch him on. Is this the place? Hold on, let's whiz it on. Here we go. Yes,
that's the place. That's the Skunk Bay footage.
Good. So this is the one I've seen before. And
so we've got time-lapse footage, and the camera's in a fixed position, so we can know it's not moving, and yeah. And yet we can see those mountains in the very far distance there, and those mountains appear to move up and down throughout the day.
Yes, because of refraction.
Yes.
So what's the problem with that?
Oh, I'm sending you an image right now.
Oh, okay.
Okay. You see that image yet?
Yeah. Let me just, see if I can grab that and show everyone else. Got him? Okay. Right. So I'm looking at it larger than people watching a stream can see. Okay. So this is 2 screen captures from that video, is it?
Yes. Yes.
Sorry,
and so we can see it's the same video, different times of the day, and in the top image you can see more of that tree. I've circled the tree there.
Yes.
Okay? You can see more of the tree, and you can see more of the mountains really far away.
Well, is it that I'm not
there's
sure
less
that you
distortion.
Sorry, go on. Please, you explain it first.
There's a lot less distortion in that top image than there is at the bottom image. There's more distortion at the bottom image.
Right. To me, with the bottom image, it looks like it's almost as though the focus is not quite so good. But focus certainly wouldn't explain the fact that tree looks about 3 times as tall in the upper half, doesn't it? But I would say that is refraction, stretching it, looming it. The mountain the mountain's easier to see in the top image than the bottom one, just due to the colours. But that looks.
So you're claiming looming effect is causing it to see more.
Not more. No, it's well, actually, perhaps is it looming or there's several different types of refraction stroke mirage, isn't there? There's Fata Morgana, looming. I'm not sure what the correct term is, but in effect, it's stretching it vertically. Look at the bush or the green area. Actually, I should be able to. Hopefully, it's my mouse code. Look at that area there, as to below. It's you're not seeing more because that island is the same. The camera hasn't moved. It's not letting you see around a curve. I'm not claiming that's seeing around a curve. I'm claiming that is stretching vertically what you can see. That's how I'd put it. And the same over here.
You're claiming the top image is stretched upward?
Yes. I'm not saying anyone's cheated. I'm not saying anyone has played with the image. What I'm saying is, due to refraction, it has stretched what you can see vertically.
You're claiming the top image is more distorted than the bottom image.
Well, or you could say the other one is more squished. I can't tell, and I guess you can't tell which is the least distorted. But that same effect, I'm going to flick back to... get rid of that. Flick back to this Black Swan one. Look at the further platform, that sort of... I don't know what part it is, the sort of the blocky square part on the right of the furthest platform. Then look at it over here. That one on the left is stretched vertically. Refraction has done that. It has stretched it vertically. It's lifting everything. It's lifted the sea. It's lifted the whole platform. Everything is being stretched vertically. I'm suggesting that it's the same effect here.
That it's getting lifted up into the air, because I thought...
Well, not in the air.
Downward refraction compresses things, right? Now you're talking about it stretching things. That's the opposite of compression.
Sorry, who said compression?
It.
I'm sorry, I did.
You were saying stretch, and sorry, I'm sorry. You were saying stretching, and I'm saying stretching is the opposite of compression. Do you agree that downward refraction tends to compress objects on the horizon?
It's upward. It's being refracted upward.
Okay, so you're claiming this is upward refraction, and wouldn't that cause the opposite effect?
No, because if you think of it, let's say there was someone stood where that tree was, okay, and they fired a baseball straight at you. It travelled absolutely straight. It fires from them or throws from them, goes in a perfectly straight path and hits you in the face, okay. But in reality, you have to throw in a curve, don't you? When you got refraction, that's the same sort of thing that's happening. The rays of light which are going slightly up come to you in an arc. They're travelling up and they get bent down. But what you see is the path of that ball that's nearest you. You look up the near side of the curve, so it would appear that the ball is come from somewhere higher. So the image, the rays of light, that's the path the rays of light take. It makes the image look higher. That's the whole thing with the sun, where the sun is setting but is still in the sky slightly. In reality, it's just dropped behind the horizon, but the light is curving up and over the horizon. With this, I'm saying that
this is downward refraction taking place or upward refraction taking place? And do you agree that they would produce opposite effects of each other?
Well, I don't know which way round you'd call it, I'll be honest. What I'm saying is that the light rays travelling from the bottom of that tree are not reaching your eyes in the same curve as the light rays from the top of the tree. Every light ray is coming in a subtly different path, and the ones at the top are travelling in more of a curve. They're travelling up higher and down to you, so it stretches what you can see.
I agree that both of the images are still experiencing the effects of refraction. They're still within the atmosphere, and so if that's what you're trying to say is that both images are refracted, then I agree.
There is always going to be refraction, but that refraction can be close to nil. But in fact, I believe it can be negative under certain odd circumstances.
So you're saying that the top image has next to nil refraction? Or?
No, I don't. Right, I don't know which one is the image that is closer to reality. I don't know. I have no way
That's
of.
the wonderful thing about being able to actually watch it throughout the entire day. Is we don't just have these two photos; we have the entire
Yes.
day. It's like 24-hour time-lapse footage, which is awesome.
But-
which is what we do not have for the black swan images. And that's
Yes,
why
we do
I
though.
think this is
With the black
superior.
swan, with the black swan.
You have
we have
time-lapse
that.
footage of that for 24/7.
Well, with black swan, we have that image, so we can see exactly.
That's not time-lapse footage.
No, but that shows you what the object actually looks like. Okay, so when you take your footage from the beach miles away, you can see which imagery looks closest to reality, and it was the image. Where are we? Oh, it's the image
so-
on the right. That's the one that looks
So you're
closer
telling
to
me
the
that
real.
the Skunk Bay image, you don't know which one is
No,
more
I have no way of telling.
representative of reality.
I'm being honest, Kyle. I have no way of telling which one is the most distorted by refraction. How can I tell? With the
Skunk Bay.
with the two images here from the black swan, we can see that the furthest platform looks closest to that on
Okay.
that right-hand image, because the left-hand image is all bent, and we know that if you go up to the platform, it looks like that. Therefore, the left-hand image must be the one that's distorted.
And you're basing this off of, okay, so you're saying that because there's more distortion here, it's more refracted. And so I can point to the
Yes.
same thing on the Skunk Bay, and when you watch it throughout the day, you can see the distortion that takes place. And so by your own reasoning, because there's more distortion, that means there's more refraction, right?
Refraction distorts it, and that Skunk Bay is a very interesting video. You can see refraction happening. I know it's a time-lapse film, but in effect, in this short video, you see it happening real time. You can see how it changes because the
You
temperature
can watch the buildings
changes.
getting compressed. I
Yes.
hope you don't think that those buildings are always, and that's how you see them in reality, is compressed buildings out there.
Yes, it's changing all the time. So with the two static images, you have no way of telling which is close to reality. With this, there are some points like that where I realise you're only seeing it on a very small screen there, Kyle. But that
all right.
that point that I've just got frozen there, it looks almost as though there's a high cliff edge. In fact, lots of the lines look vertical because it's been stretched up just above the shoreline, and then other times that all but disappears. Yeah, because you're looking through a temperature gradient, and it's a temperature gradient that changes, and as the temperature gradient changes, the light rays get bent differently. Therefore, what you see is different at different times. But there are ideal conditions where refraction is at its minimum. That's the one you should use. You don't use the one picture. I'm not talking about you, but the black swan. They're using basically the one picture where you can see beyond the furthest platform, and the cranes are bent, and the actual whole shape of the platform is stretched vertically. They're using that one picture and claiming that as evidence. That's the wrong way to do it. I mean, here
Yeah,
we've
that's why I like this, is because we have a full time-lapse image, and that way we have much more to observe.
Yes.
So that's why I say
And
this footage is superior to the black swan, because we can observe it all the way throughout the day.
I think it's different. I don't know. I mean, this bit
We can
here.
see that
Looking
horizon-
at this, the way that's
acting like a
stretching,
boat.
stretching up and down. I mean, that's beautiful. It really shows how refraction is a thing. How refraction can have a massive effect. It's great. Okay. I better have a look at your. Let me just switch the thing back off again. Make sure we've covered the other things that. Okay, so we talked about refraction. We talked about penumbra. We talked about divergence of light, where you said about sunlight all the year. I think perhaps that was a bad phrase, because I thought you were saying if it was parallel, we wouldn't get light all year round. I'm not really sure about that. But your other thing
That is
was
what I said. If it was parallel, we would not get light all year round, because I'm talking about all of the light from the sun, not just a specific amount of light.
yeah. So yeah, you triggered an alarm with me there, but I think later on we've established that that wasn't quite what you were saying, so that's fine.
That's
The
where
other,
it's nice to have parameters at the very beginning that are established. And so we've got to talk about, if we're talking about light from the sun, we got to talk about what light from the sun. Because I'm just talking about all of the light from the sun in that opening. And then as we continued further, then I kind of narrowed it down and talked about more specific amounts of light from the sun. And so when we look at Penumbra, we're obviously not looking at all of the light from the sun.
well, the other thing you had was light dims over distance, sunset,
Yes.
and you're saying about the sunset dimming.
Uh-huh.
Do you want to just expand on that a little, just a little, to explain your position and or what you're saying?
Light. Okay, well, the light immediately around the sun, if we just look at the sky itself, all of the light around the sun is the brightest. We can actually get the luminosity scale of the sky, and as it gets closer to the sun, it's a lot brighter. But as we get farther away from the sun, it gets a lot dimmer. That's because the light diverges,
Well, if
just like a candle. So my example, I can show you a picture, is of a candle in a room.
okay, I think we did see that. Let me just call your video up, Kyle. Just bear with me a second. Where is it? Oh, have you taken it down?
Oh, it's still there.
Uh,
Light from the sun is not parallel. It's just the title of my video. And
I can't
here
see it.
is my example of the. Well, I can give you a link if you need one.
yeah, please, because for some reason it's not showing up for me. Yeah, if you just
Alright.
DM it to me. Oh, and by the way, someone sent me a message. That business when I was trying to very poorly explain about things stretching upwards, that is called towering. That's the technical term for it. So you've got towering, looming, Fata Morgana, and so on. Towering.
Sorry, that's the wrong link. That's the
Oh,
wrong
okay,
link.
okay.
Let me grab that.
Because I had seen your video.
Yeah, and so I'm wondering if there's any part of that video that you even disagree with. So,
Well, I can't see it on your channel. Have you? Can you?
okay, here we go. Here we
Okay,
go.
yeah,
This
that's the one.
that's the way.
Right, let me just open that up. Where's it gone? Okay, so I'm not going to play the video. If anyone wants to see the whole video, it should be somewhere on Carl's channel. But it was the candle bit, wasn't it?
Yeah. But if there's any part of that video that you actually disagree with, I really want to know, because I would be very surprised if there's any part that, yeah.
Well, I've got the candle there. So what was it you wanted to say about the candle?
Oh, the candle is a nice example of this candle is a nice example of the gradient. We see the light gets a lot denser as it gets closer to the flame, and then it gets a lot more sparse as it gets to be dimmer the farther it gets away from the flame. And when we look at the sky, when the sun is out, the sky does the exact same thing.
Right. Well, I'm okay. Looking at that candle, Kyle. When you're looking straight at the flame, the light that's travelling from that flame that hits your eyes, that's the light you see. The light that travels and misses your eyes, you don't see at all. The only reason you see anything other than the actual flame, like for instance the wax at the top of the candle, how bright that is, how bright it is a few millimeters away from the candle, that's reflection of light rays, like the wall right behind the candle. So some light rays from the back side of the flame have hit the wall, bounced off it, and then travelled to you. That's how you see. You see the reflected light. So as you get further away from the candle, the angle that light rays bounce off that wall will be different. So less and less. I mean, it's a pretty smooth wall, but it's not glass smooth, of course. It's got the ripples that you get on a painted surface. So as you get further and further away, less and less of the rays are going to strike at an angle that bounces off and hits your eyes. So you're not going to see them. so it's going to look dimmer.
Yeah, so do you agree with me that the light from the candle is diverging in all directions throughout the room, and as the light gets farther and farther away, the greater the angle becomes? Or I guess it's all the same angle, but the more distance between the rays occurs.
Yeah, Rob. And we talk about rays, but in effect, it's an almost solid, outwardly growing sphere of photons. But talking of individual rays, yeah, that's fine. So that light source
So
is
we
now.
have two rays that diverge, and so that means they go farther and farther apart as they.
Yes, well, that light
get farther away
source,
from
the flame of the candle, talking left to right, is narrower than the distance between your eyes, isn't it? Obviously. So therefore, light rays, as they hit your left and right eye, are divergent. Because it's a light source that's smaller than you are.
I like that. I like that point. The candle is probably as small as my eye.
Yeah. In fact, if you close one eye, I guess the width of a candle flame is not much bigger than the width of your iris. In which case, I would say that the rays of light travelling from that candle flame hitting the one iris are parallel. But there's light rays going off in every other direction as well. I mean, I'm not sure how far away that candle is from you, but it looks as though the width of the flame is smaller than the width of the sun in the sky. We know the width of the sun in the sky is just over half a degree. I mean, let's say that candle appears as half the width of the sun. I don't think it is, but that would mean that those rays that hit your individual eye are parallel to within a quarter of a degree. So it's more parallel than the light coming from the sun.
You think that the light from the candle is more parallel than the light coming from the sun? That's what you just said?
The light that... Excuse me, I need a swig of a drink. The light that hits your one eye. We have the other eye closed, because otherwise you've got two eyes and they're, however, I don't know, 3 inches apart or whatever it is, which is obviously wider than the candle. So rays of light hitting your right eye and left eye are diverging from each other. So if we closed one eye, we're looking with just one eye, the rays of light that hit that one eye, that one iris, are very close to parallel. But there's light going in every other direction as well.
Okay, I'm just thinking about my eye and my eyeless, my iris, and the way my eye works as a lens. It's got a big lens on it that ends up diverting the light so it can focus on the. No, that's what it is.
I'm sorry. So I just did see a silly comment by Dr. Dino saying only 3 more candles and you got a fork handle sketch. Fork handles? You got any fork handles? Sorry, I don't know if you'd get that, Kyle. It's a British comedy thing, so don't worry about it. Okay. Right. Well, I'm not sure. I think we've. Is there anything else you want to cover? Because I think we've covered all the things, the points that you mentioned.
Yeah, I think that covers them all. So we got light dimming over a distance because the rays get farther apart, and I mean,
yeah, go on.
I'm really looking for which of these that you actually disagree with and which ones you actually agree with, because this has been really vague on your part on that one. I think you said earlier that common ground is banned here. I'm like,
no, I wasn't saying that. I was just trying to because I wanted this to be a discussion, and for you to try and defend whatever position you have, and me to defend the position I have. There may be some overlap, and I think there was, which I guess you'd call common ground. But what I didn't want this to be is just a let's see how nice we can be and how much we can possibly agree with. I wanted us to be a bit, and I think you have, Kyle. You've tried to put forward your views more strongly, and I have too, deliberately so. And it's not to be nasty or to try and start an argument, but I just think if we're having to argue our case more, we can both learn more.
Yeah, and I'm all about that, and so I don't really feel like there's a lot of need to continue on arguing about something that we both agree with. And so that's where I like to have to know where the boundaries are. I like to know, okay, you do agree with me on this, so therefore we don't need to argue about that anymore because we can move on. We can move past that point.
Yeah,
But
I know.
you do disagree with this, and so yeah, and that's why I can point to that video and I'm like, okay, is there any part of that video that you actually disagree with?
Okay, well, I
if
did.
not, then what are we arguing about?
Yeah, we're talking about the. You're talking about the light getting dimmer. Well, light will keep travelling. Now, the light. If you've got that candle at night outside, forget wind, but you've got a candle outside, you could go quite a distance before you can no longer see that there is a light of some sort there. But eventually, you'll reach a distance, leaving aside any objects and things that could be in the way. You'll get a distance where the candle light appears too dim to see. I think we'd agree on that. But that's due to light scattering. We have an atmosphere, so there's oxygen, nitrogen, etc.
That breaks the parallel lines.
Well,
right?
it scatters it, but it also intercepts photons. It
absorbs it as well.
In effect, yes. Now, if we were in a vacuum,
when I was in the army, we learned about our flashlights and about how we don't always walk around with white flashlights on, but we often put a red lens over it because we don't want people to see as far. We want to be visible to those around us, but we don't want to be visible to people who are miles away. And if we were to have white flashlights, then it would be much more visible to people farther away.
This is true. But if we were in a vacuum, so there was no light scattering, several things. First of all, we wouldn't have refraction, so that business of the sun dropping behind the horizon, as it's dropping behind the horizon, it really is dropping behind the horizon. And with that candle, impossibly burning in a vacuum, of course, but with that candle, you would get no light scattering, so you'd see it from an immensely greater distance. Starlight is travelling across light years. We use larger and larger telescopes, not because they magnify more, but because in effect they've got bigger eyes to capture more photons. Or you don't just when you're doing astrophotography, you don't just take a snap of the sky. You might leave the shutter open for quite some time to gather more photons, because at the distances we're talking about, less and less photons are reaching us. That's what I was going to say about dimming.
Okay, yeah. So I can agree that there's an atmospheric gradient that I call it atmospheric opacity, and I agree that atmospheric opacity can cause light to get dimmer over distance.
Yeah,
that's what you're talking about.
Which is when you said sunset dims, that's because as it's going down, I mean, the sun is not changing its brightness whatsoever, but what's happening is the light is getting more scattered as it's travelling through more of the atmosphere, so less of the actual photons are hitting your little eyeballs.
Okay, and so scattered light is not parallel. I hope we can agree.
Yeah, I mean it's bouncing around all over the place by then.
Okay,
right, so
we agree.
So I don't know. I think I saw some super chats come in. I had to I'll unpin that message now. I had pinned a message to the top saying any super chats will be held to the end, because I didn't want us to get interrupted left, right, and centre, Kyle. To hopefully have more of a fluid discussion, which I think we did. So there may be some questions in here for you, okay? Okay. Right, let me just go back a bit. One thing I do want to say is between the last stream and this stream, Mr. Bill Devitt became a member of the channel. Thank you very much, Bill. I hope you are watching right now. So welcome aboard. Right, the first message is from someone called GPS, super chat $5, and asked Kyle, if anyone can mirror your videos like you have said, why did you file 2 strikes against me for mirroring 2 of them? Do you know anything about that?
GPS. I don't recall. Yeah, I'm not sure if.
Well, okay. Because I have no knowledge of this whatsoever, so it's an open, honest question. I mean, I've had to issue a strike against someone some time back. Have you issued any strikes?
I have issued some strikes from some people who are yeah, uh, copying my entire video, kind of a thing, not just doing the selective things, unless I have permission. And with some people who are clearly sharing it on their channel, like Globebusters, I haven't. They've mirrored some of my videos before, and I'm totally okay with that. And so there are people who I'm okay with them mirroring, and there are people who I'm not okay with them mirroring, and that's kind of how it goes.
Yeah, there is a difference between the two things, though, isn't it? A mirror is basically an entire copy, which
Yes.
I mean, I have given permission for some people to mirror a video. I have mirrored a video of others with their permission. That's a totally separate thing from me, let's say, taking your sunlight video, this one we're just having a look at, and doing a breakdown where I show a bit of your video, I
So
argue against it.
I like communication.
That's fair use. That's allowed legally. But I think what this guy is saying is, and I don't know if it's the case, because he says if anyone can mirror your videos like you have said. So I don't know if you mentioned that in a video.
Where have I said that?
Okay, so you're okay. So you're saying that that's not the case. Okay, well,
I've never said that.
Okay, fair enough. Actually, just as an aside, Carl, you said about Globebusters, whatever, mirroring a video. I did see one of your previous videos. I can't remember which one it was. It's the one where you used the polarized lenses looking at the. Do you remember?
Huh? Yeah.
Yeah. But I saw that video all over the place. It was on Mitchell from Australia. It was on here, there, and everywhere. I don't know if
I'm getting ready to do a sequel to that one. I'm really excited about doing that. I just feel so bad it's taken so long to do it. I really cannot wait to get that one out. It's the video that I am most excited about right now.
Okay,
it's going to be called. It's going to be called Shadow Origami, and it's going to be awesome.
Okay. Well, I'm not talking about the contents of it. I'm actually thinking on your behalf. It looked like Kyle, as though an awful lot of people were getting content and advertising on that content with your work. If I were you, I might consider asking them only to show portions and point them back to your channel, so you get the benefit of the views from your work.
Oh, I got plenty of benefit from that.
Okay.
I got plenty of benefit from it. So when Globebusters shared that with me, I got a lot of traffic to my channel just by that, and so I'm totally okay with that.
Cool.
So yeah,
that's all right.
Just them mentioning me was a huge privilege for me. So
I just didn't
really
want you to be taken advantage of by others. Okay, fair enough. Right, the next one was from IMD Fox for €1.99. Says COVID free for 23. He had posted earlier in a chat saying that that's his new. I'm not sure if motto is the right word, but COVID free for 23. Wants to get past COVID for next year, which I think we probably all do.
I appreciate hearing news other than that. I listen to a lot of NPR, and that's all they talk about. I was like, come on, give me some different news.
The next one is super chat from Earth is Life for $5. Beg your pardon. Says, if I stand on a sideline, open American football field, and look to the other sideline, are the lines parallel or do they appear to converge?
Well, they definitely appear to converge because it's called perspective. Vanishing point. They're just yeah.
Yep. Well,
when you learn about drawing, you learn about vanishing points.
Well, you are very obviously aware of that, Kyle, unlike certain flat earthers who don't seem to be aware of it. But you obviously are. Yes, perspective is a thing. Those lines are indeed parallel. Otherwise, it would make sense to do your down on the right-hand side of the picture, wherever it is, where they're narrower. So, it would mean yards are shorter on one side than the other, wouldn't it? Okay.
I actually used that in a point about how high the horizon appears to be. If it's whether... So the vanishing point can actually point to your eye level, depending on the amount of atmosphere in the sky. But I did a video about eye level, talked about that in detail.
Okay. Well, one thing where I'm not accusing you because I don't know, but a lot of flat earthers seem to confuse vanishing point with eye level with line of sight. So if my eyeballs are 6 foot above the ground and I'm looking straight forward, that's eye level, and the line of sight is what I'm looking at. But if I'm looking up towards the top of the building, my eyeballs are. If I look up to the top of the building, my eyeballs are still at 6 foot above the ground, but my line of sight is now pointing upwards. But obviously, that's not what we're covering.
I get that. Eye level is different from line of sight. Yes.
Right, from Alyssum, I think that's how you say it, for 5 shiny Australian upside down dollars, says, Kyle, why is there no flat earth based navigational techniques? Why do I have to account for the globe whenever I want to calculate my flight distance?
I've never heard of any flat earth navigational techniques. I'm pretty sure people have been using celestial navigation far longer than the globe earth model has existed. But that's just
celestial navigation is based on the globe, though, isn't it? If you're talking about
no, it's not. It's just based on the stars.
Yeah, but that's angle. Right, we're going to get into sextants if we're not careful. The reading when you take a reading of the star, giving your latitude around the curve of the Earth from north, it doesn't work on a flat plane. If I'm right under the pole star's 90 degrees above me. If I move a certain distance away, 69 miles away, that pole star will be now 1 degree off of vertical. Another 69 miles is 2 degrees. If that was flat, if the Earth was flat, it wouldn't work, because each time you go further and further away, the star would start dropping more and more slowly.
Okay, we both agree that perspective is a thing, right? And
not with regard to that, though.
Vanishing points are a thing. Okay, we both agree that there's vanishing points, and we agree on that. We also agree on refraction, that atmospheric refraction exists. And so those are like 2 major principles that talk about why the Polaris can't be seen like south of the equator.
Right. First of all, with the refraction, I'd already said when we first started, refraction doesn't really come into any distortion of the position of the stars above about 15 degrees above the horizon. And as you get closer and closer to the horizon, it will distort more and more. I wouldn't mind having a debate about this sometime, Kyle.
Okay. Sounds fun.
Yeah. Okay.
Yeah, because I can think of a lot of instances of that. And so, yeah, there's only refraction just really right close to the horizon, but there's not very much up there. But yeah, there's still atmosphere up there. That's still going to take place so long as there's atmosphere. So, yeah.
Yeah.
Snell's law doesn't cease to exist the moment you get above 15 degrees above the horizon.
But with the temperature gradient, it's like with Snell's law, the angle, I can't remember what they're both called, but the angle of incidence, the angle you hit that differing density, affects the way the light ray proceeds after that, doesn't it? So if you hit it at 90 degrees, it'll either go straight through or bounce straight back. If you hit it a few degrees off, and so on. So as you're going, looking at something closer and closer.
30 degrees is not 90 degrees. Okay, so I'm saying at 30 degrees, Snell's law should still have an effect.
But what I'm saying is, as you get lower down, you're looking through a greater and greater amount of atmosphere. Therefore, it allows for a greater and greater amount of refraction. When you're looking vertically, I mean, Mage flew up to 38 kilometres, and by the time you're up there is next to no atmosphere. There was barely any. And if you were looking straight up at Mage, any temperature gradient... What?
I'm sorry, I'm just thinking about if you've ever seen the moon as seen from the ISS, and you can see it, and it looks like really, really, really refracted and like.
Well, I haven't seen that. Perhaps you can send me.
I haven't done a video. I've been sitting on that one forever. But,
okay.
Oh my goodness.
Okay.
It's hilarious.
But if you're looking straight up, then you're looking straight through the temperature gradient, the angle of incidence of the light rays between me and Mage directly above my head. You're hitting and passing through that temperature gradient at 90 degrees. If, however, Mage was over towards the horizon, the temperature you're going through that gradient at a steeper, or sorry, shallower angle, if you know what I mean. So it's going to deflect the light totally differently. But basically, if you're looking upright, if you're looking straight up, there's only 20 odd miles of atmosphere, and it gets less and less very quickly. If you're looking straight ahead, there's an awful lot more atmosphere that you're going through.
Now we're getting into Eratosthenes, because I've got 2 videos on refraction and light from the sun not being parallel. Number 1 was my original video. I think that was my very first video that I got published when it came to me starting my whole flat Earth series. Was the Eratosthenes was wrong, and that was one of the things I talked about. And I talked about just with the globe model, they talk about all of this solar wind, and about how the qualities of solar wind will refract the light that passes through it. And I talked about all that. And so it's not just a matter of the Earth's atmosphere on the globe model that's going to refract light, but it's also solar wind and the other gases in space that would cause it to refract light on the globe model that no one takes into consideration whatsoever.
Well, I've never heard anyone mention about refraction due to the extremely sparse level of gases, for instance, between us and the sun, or with regard to solar wind. I've not heard any claims, so I've not looked into it.
93 million miles of solar wind. It might be really
which is all streaming straight towards us. It's all streaming in straight lines out from the sun.
No. The solar wind is not going in straight lines out from the sun.
Well,
the sun is constantly spewing solar wind in all directions according to the globe model. So it's
but if it ejects particles, those particles travel in straight lines, don't they?
Well,
just hold on.
Well, it depends on what kind of traffic they're hitting.
Well, there's nothing to let me just. It's just the same as that. Particles are being injected in every single direction, and they're traveling straight lines, just like the photons.
Until they bump into some kind of resistance, because the sun is supposed to have a ton of gravity, and it's supposed to be sucking things towards it, right? And so therefore you're going to have some kind of traffic. There's going to be matter being ejected from the sun, but there's also going to be matter being pulled toward the sun. And so when particles of gas get hit by or touch different kinds of space dust, that's going to cause them to divert from their original path, right? Just like I'm thinking about.
Well, if they hit but it's the solar wind. By definition, are particles coming from the sun. So that if you have some particles streaming towards the Earth, and the light photons are streaming towards the Earth, they're all coming at us in a straight line. So I don't see how they can get refracted. But perhaps this is a discussion for another day. Perhaps.
Okay, yeah, it's another video, and so I really enjoy those videos that you do where you actually watch the video and then you do your commentary on it, because that gives me specific areas, and that's what I really like to look for. What specific areas of my video are you disagreeing with? Because so far, we've kind of discussed my video on the light from the sun not being parallel, but so far I am not aware of a single part of that video that you actually disagree with. We've been talking about parallel and non-parallel, but I don't have any specific claims that you're in disagreement with me on that. And the same thing goes for the Eratosthenes video, which I haven't brought up to you until just now. But yeah, those are the 2 major things that are kind of on very similar lines of thought.
When it comes to when you're discussing about the light coming out from the sun in all different directions, therefore it cannot be parallel. I'll be honest, I thought that's a silly claim, because it's a sphere with light going in every direction. Nobody is saying that all the light coming from the sun is streaming in one direction in a parallel fashion. All we're saying is the light that actually we see, the light that hits the Earth, is virtually parallel. As for the rest of it, yes, it's going off in every direction. But then if you viewed the sun from another location, the light rays that hit you are virtually parallel as well. They're just not parallel with the light rays that are travelling to another planet.
Okay, and so I'm looking for the exact statement you're disagreeing with here.
Yeah, I know what you mean. I know what you mean. I, th- if you're, because you mention it in your video, that the light going everywhere, therefore it's not parallel. If you were actually claiming that we are wrong, we are saying that all the light is parallel, all of it, then I would
That's where I'm
have
very
a
careful in
problem
my
with it.
video.
Yeah, but
That's where I'm very careful in my videos about exactly saying who I'm disagreeing with and why. And so,
yeah,
if
well,
I'm saying I'm
as you're not
disagreeing with
saying
someone, I'm
that, I'm
actually
not
giving it, like, a
disagreeing,
direct
Carl.
quote.
Carl, as you're not saying
Okay.
that, I'm not disagreeing. You know, had you been saying that, oh, these globe is saying that all the light from the sun is parallel towards us, then I'd say, hold on a minute, Carl, that's not what we're saying. However, you're not saying that about us, so that's all right.
Yeah.
Okay. Right, I will say, if anyone else, I've got a few more super chats to read out. If anyone else wants to super chat while we're going through them, now's the time. The next one is, I nearly missed it. Glad I didn't. From Flow Rider. Arnold has forgotten more about physics than Kyle will ever know. Hashtag we want Arnold.
Dark side is strong with this one.
Unfortunately, Flo, Arnold's not here tonight. Last I saw, he was curled up in the middle of a double bed. He's a lazy so-and-so tonight. But thank you for the super chat. The next one is also from Flow Rider for €5. Says, for your information, I am on zooniverse.org helping actual scientists analysing actual data. So the time listening to Kyle's BS does not feel wasted. Sorry, Kyle. Well, you're taking it in good stead. That's all right. Second best, Bob. Super chatted £10. Thank you, Bob. Yeah, thanks, Bob. Money for your sensibleness. And a smiley face with love hearts. Well, thank you very much, Bob. I appreciate that. And John Rapp super chatted $2 Australian. Not sure refraction is fully covered these 5 years. These 5 years. I'm not quite sure what he means by that. Any idea what he might mean by that? Not sure refraction is fully covered by these 5 YRS, which I assume is 5 years. Unless I'm missing something. Anything else? Does that mean anything else to you, Kyle?
With
It
no,
does.
I
It
have
doesn't
no
to
idea what
me.
he's talking about.
Yeah, I'm not sure either. But thanks for the super chat, John. And Pat G super chatted $2. Says, Kyle, thoughts on the turning torso video? I know nothing of that. Do you know what that is? The turning torso video?
Can't say I've heard of the turning torso video.
No, nor have I. I don't know what
It's
that
like
is.
someone dancing. I can do the twist.
I really don't know. I really don't know. But thanks for the super chat, Pat.
Yeah, like it
Now,
like this.
Kyle, you're obviously very happy. I want to bring up something else, if I may. And I'm not. Hold on, let me just see. Where am I? Sorry, I'm just losing where. I've got it. I want to bring up something else and discuss something with you. Let me just bring this over. I saw this video today, Kyle. I'd like to discuss it with you.
Oh, yeah. Okay.
I don't know if anyone else has seen this. I haven't got the sound on. I'll jump it forward a bit to where something's happening. I presume this is your daughter, is it? Or one of them?
Yes, that's my daughter.
And I'll just say, what a beautiful child she is. Oh, is that his son behind? Or is that a neighbour's?
That's my son.
That's your son.
That's my son.
Right, well, yeah, very nice looking kids.
I've got 2 additional daughters, and one was just being shy, and the other one was sleeping. So.
Okay,
Yeah.
okay. Right, so I'll just leave this playing for a little while anyway. That's an axe she's got, isn't it? And I'm not commenting on the fact it's an axe, because I think there's nothing wrong with teaching kids how to use a tool, okay? But I wonder, can you explain what she's doing at all, Kyle?
She's smashing the globe.
Why?
I
Why?
gave it to her and said, yeah, I gave it to her. She's having fun. So, what do you want to do with it? She's like, let's smash it. I'm like, okay, let's do it.
I'm just a little concerned with it, really. And as I said,
Well,
not because it's an axe, because I don't know how much safety you've taught her about axes, and kids need to learn about.
I've got the comment that we probably should have had some safety goggles on her.
Yes, I saw that, and that was a good comment.
I kind of acknowledge it afterwards.
Yes, I saw you did.
I agree. She should have had some safety goggles, especially when it got kind of bounced back at her. But
I'm not talking about the safety aspect. I mean, I thought the goggles comment was that's absolutely right, but I didn't think of that either at the time of watching the video. But let me just pause it. But I'm talking about why she's doing what she's doing. I actually find it quite concerning.
Okay, so why do you find it concerning? If it was a flat Earth model, would that concern you? So if she were to be
okay, I'm going to be
smashing the flat Earth
painfully
model-
honest, and I'd have to say if it was a flat Earth model, that's true. I probably wouldn't be quite so concerned, which is wrong in a way.
You're concerned about it because of just kind of your own personal bias towards it, and the more concern that generates with people, the more I see it as the more it feels like she's smashing some kind of an idol of some sort. And so, yeah, I kind of see that, and it's kind of a nice, kind of freeing moment, saying, hey, this is just a globe. There's no need to feel any kind of attachment towards it. It's just a globe. It's their model, and so
it's not the physical object I'm talking about, because I mean let's say that the globe itself was busted, the stand broken or something. You're gonna throw it away if it's not repairable. So it's not that in itself. It's more what it stands for. The reason I feel so uncomfortable about it is it's like, well, it's denying science. I know that you have your personal opinions or beliefs or understandings or misunderstandings, however you want to put it, but you've got your views, your position with regard to flat Earth, globe Earth. But I don't know.
We've kind of defined science before. We've established common ground in the definition of science before.
Do you homeschool? And I'll be clear here, I am not against homeschooling per se, but I'm just a question. Do you homeschool, or do they attend school full-time or part-time?
Up until just this year, they have been homeschooled. It's been an online public school is what it was. It was just online. But this year, they've actually gone forward. And that's how she was actually able to get ahead a year in school. They were able to skip kindergarten because we did... it's called the Utah Virtual Academy, or what's it called? K-12 is the program that they have in the U.S. And they're all very advanced for their age when it came to like reading and writing at a young age. And so when we went to the public school at first to enroll them in kindergarten, they wanted them to go through all of kindergarten on their own, even though they already knew this stuff. I'm like, why do we want to do that? And they're like, oh, well, we're more concerned about them being in their own age group. I'm just like, forget that. And so we ended up going through online school because we could go at our own pace. And so because of that, my two oldest kids here, Melody here, she's a whole year ahead of everyone else in her own age group.
Well, that is something to be proud of. I have, I don't doubt that. I have no qualms of saying that. For instance, if it's a reading, writing, maths, and whatever else, if she's ahead, she's ahead, and that's a credit to you. My concern is
we did that for a while. Now she's gone and rejoined with the rest of.
Okay, so she's attending class with other kids.
Yes.
Do you not feel you're setting her up for problems? Because you're not just presenting. Look, here is a view. The standard view based on science. Here is a view of flat Earth, which I personally hold and so many other people hold, because based on this, you're not even providing that. It's almost as though, well, I want to show you a picture, okay? This is something it made me think of, Kyle, okay? I'm trying to be very careful in what I'm saying, all right? Please don't read anything into this beyond what I'm about to show you, okay? Kyle?
Okay, I'm listening.
Okay. This.
Burning books kind of a thing?
Burning books. Yeah. That's what it reminds me of. That's the first thing that sprung to mind. You might disagree with what's in those books. I mean, I've no idea what's in those books. You might disagree with what's in those books or what they stand for, but that sort of destruction, it's closing your mind off to what is in those books. It's closing your mind off to science and the globe.
And I kind of feel the same way every time, a flat earther's YouTube channel gets taken down for this reason or that reason. And, you can kind of argue, oh, well, about accuracy of the information. And, I can look at each of those videos. I'm sure those people burning the books are like, oh, well, they're bad books because they're inaccurate and wrong. And so I look at this as there's an actual war of information going on right now.
Well,
in the community, and so
YouTube don't take down
my video recently.
Well, sorry, you said about YouTube taking channels down. They don't take them down because they're flat Earth. They don't. The ones that, get taken down are the ones, for instance, if they're racist or hate-filled, basically with the community strikes or copywriting. Your channel's there. I don't believe you've got any strikes against you, have you?
No.
And from what I've seen, I could disagree with everything you said, but there's no reason to strike it. You're not breaching copyright. You're not abusive. You're not spewing hate and so on.
I do my best to follow the rules.
Yeah, and so your channel stays. But some of those other channels have had such bile in them, Kyle, and that's totally different than just holding a different opinion.
So, the whole conversation of controversial medical procedures, for example, that's been the biggest killer out there. Is controversial medical procedures.
Do you realise what happened to me recently?
So that would be an example.
Well, what happened to
vaguely,
me?
You'd have to remind me.
Yeah, that's fine. I don't expect you to follow all my videos, just most of them. Someone had done a video with regard to all that sort of stuff. I did a debunk.
Oh yeah, you post.
Yeah, I did a debunk video, which it was going to premiere, and YouTube took it down about 30 minutes before it premiered. I appealed, and they said, no, it's medical misinformation. Now, so they were complaining about the contents of the video. The contents of the video was what I was debunking. Okay.
You're mad at them for burning your book, even though they never read it.
Yeah, well, that's the biggest point. They didn't even read it to then decide. No. And what's really funny is Mr. 42 took it on himself with my agreement, and he hosted the same video. And last I heard, it's still up there. So they're not even consistent. So the same video that they took down on mine is still up on his channel. But yeah, so with Flat Earth, obviously I disagree with Flat Earth, absolutely. But
that's okay. That's okay.
Yeah, but I agree with your right, even if it grinds my gears and thinks, oh, I wish people wouldn't watch this. Even if that was the case, you still have a right to say that, as long as you're not breaching the standards of YouTube. So that's not a problem. But with that video, with the video with your girl, I think you said Melody, which is a nice name. It just makes me feel that you're not saying, look, that there is this idea and this theory, this is the consensus, but I disagree with it. I could understand that, but it's almost as though, maybe I'm reading more into it than it is, but it made me feel uncomfortable because it made me feel of burning books, destroying what you disagree with. And that made me uncomfortable, I'll be honest.
There's a difference between erasing history, kind of all records of history. So if we were to take all of the books in the country and decide to burn these specific books because they talk about things, that's taking it to a whole nother level. But we're not worried about them suddenly running out of globes in the country. We're not trying to erase history or anything like that. But it's kind of, I'm just trying to think of like shooting a hole through a flag, kind of saying that we're at war with the globe model. And so that's kind of a declaration of war, I guess you could say.
Okay, but
a statement of saying which side we're on.
I mean, I'm not stupid. I realise there's a humorous side to it as well. I do realise that. Okay, and I think I've made my point, Kyle, and I haven't got you on here so that I can try and beat you up about it. But just, but my opinion is,
we've had a great conversation so far.
Yeah. Well, okay. as a parent then, let me just... You don't have to respond to this. I'm not asking you to respond. All I would ask is that you give great care to what you tell your children, what you expose them to with regard to ideas and so on. I'm not telling you what to, but I'm just saying, please take great care, and also consider how they'll be with the other kids in the school. Okay? Oh, they look like lovely kids. Okay? So I've said my piece, so I think I'll leave it there. Okay?
Yeah.
Okay, thank you. There's a few more super chats have come in. Right, so we had the turning torso video. I don't know what that is. Second best Bob, super chatted £2, says, see you in Oakley's chat soon. Yeah, I do tend to go in there when I'm bored and I want to stir up and have a bit of an argument. David Oliver, super chatted £5, saying, I've got no more symptoms now, but I did test positive with a faint line, but still positive, so I'm on the mend. Feel great again. A heart and an upside down smiley face. Well, I'm glad, David, if you've been suffering. I'm glad if you're getting better. My understanding is with PCR, you can test positive for many weeks if you had Charlie 19. I don't know about with the lateral flow, but actually think about it. Here in the UK now, I think if you test negative on days 5 and 6, you can end your isolation. But if you're still positive, you obviously still have to remain isolated. But after 10 days, even if you're still testing positive, you can end isolation because it's just the test picking it up. But I'm glad if you're feeling better. Andy B123, super chat £5, said, and this is, I guess is more with regard to yourself, Kyle. How come you can see stars on the horizon, but not the sun, quote, gone too far away to see when it is set? Yeah, so how can you see faint little stars near the horizon, but the sun disappears? I guess how can you explain how can you explain sunsets? Well, what is your explanation briefly for a sunset, Kyle? What is actually happening?
I've got several videos about that one. That's all of lesson 4, and lesson 4 is broken up into multiple parts. And so all of lesson 4 is talking about observations of the sun. And so I talk about observation of sunsets with a large amount of refraction, though. And the entire reason why the sun goes down is because of refraction. And so I don't know. That's
well, yeah, I'd obviously disagree. And if it refracted it down, why can you reach the point where you can have, depending on the light, a sort of perfect upper half of a circle showing, the upper half of the spherical sun showing, and nothing of the bottom half? And yet you can have stars near the horizon.
It's the same thing with the boats on the horizon. It's why the boat appeared to be sinking that's going back to my fish tank laser experiment. That was demonstrated. So the same thing is happening to the sun as was happening to the boat.
Okay. And John Rapper super chatted $2 Australian. Aussie smartasserism. It's been argued to death. I don't know what the smartasserism was, John Rapp, and what exactly has been argued to death. I guess Flat Earth Globe has really.
When something gets argued to death and goes on and on and on, that's the only reason why that's happening is because not enough common ground has been established. But the moment you can start establishing that common ground between two people, the less they have to argue about. That's when you get out of the downward death spiral of disagreement.
Oh, sorry, I haven't cut you off, have I, Kyle? Hello?
Oh,
good. I suddenly thought I just cut you off. I was just going to... I got... I think this is the last super chat from Sarcastic Barman for £10. Says, Flat Earth channels are not getting taken down for being Flat Earth. They're taken down for other naughty things. To say otherwise is moronic. I mean, can you think of channels, Flat Earth channels that be taken down? People like Nathan Oakley... Nathan Thompson, but then he was doing things like bothering kids outside schools and stuff like that, and I don't know what his channel was actually taken down for.
I can think of our number one Flat Earth channel out there. They just recently had their channel taken down, and that was probably because they were talking about controversial medical procedures. That was what it was.
So
I talked about that in my top 20 list. But there's been a number of different people throughout over time that have had their channels taken down, and I keep track of all that in my Flat Earth News series. That I get like and lately I've been doing it like twice a year, where I do like a mid-year report and then an annual report. And so I just barely did that one for January.
Yeah, but what are those channels taken down for? Because if you get a strike, or a copyright strike, or other warning, YouTube tell you why. For instance, in my case, I got a warning for this medical misinformation. That's why. Now, I disagree with it. It's a load of bunkum, because it's happily sat up on Mr. 42's channel. He's confirmed that it's still there. And in fact, it wasn't my information. The information is there, and it's still there on YouTube. I have then taken that and debunked it.
Because I look at the FE 101 channel. They are that was the number one channel there forever, and they hold the record for having the most subscribers for a Flat Earth channel. And I do not know why their channel got deleted.
Obviously, they do. Well, this is the thing. They do. You see, one of your colleagues' channels then suddenly disappears, and I'll be honest, there's a lot of this conspiracy. It's been taken down because of the Illuminati, or NASA shills have been paid to take it down, or whatever, with no evidence. And yet they will have messages from YouTube saying, for instance, for medical misinformation, for copyright strikes, for hate speech, or whatever. But they're not going to say that. They're just going to say, we're being silenced. That's the problem. I mean, when we've seen issues where a globe side, if I just finish off, where we've seen issues where a globe side channel has been copyright stricken or has been taken down, we know why. We disagree with it, but we know what the reasoning is. We're not just going to say it's a conspiracy. I'm not saying you're claiming that, Kyle, but that's what we hear time and time again from many flat earthers: is conspiracy, Illuminati, the elite, with no evidence.
Okay. Well, I have the evidence of the Flat Earth censorship coming out, and I don't know if you've ever seen the court hearing where YouTube was in court, and they're like, okay, well, what are you guys doing about the Flat Earth movement? And so they talk, oh, well, we're going to put all these little banners at the bottom of each of our videos that says that, it's an archaic concept and all this stuff, and scientifically debunked, and and so that whole banner in every single Flat Earth video you see is evidence of this kind of, there's a movement against it. Does that make sense?
Well, yes, I've seen those, obviously, and they're appearing on every Flat Earth video. But if they were a movement against, why don't they just shut all your channels? Why don't they just ban any video that is pro-Flat Earth? They're not stopping you. They're just letting people know.
On their part. There's a difference between stopping and there's a difference between slowing down. And
yes, well, that's what it's. I mean,
can all agree that
with the YouTube algorithms, when you do a video, it will show it a few times on the home page or suggest it to people. If no one clicks on that video, they'll stop suggesting it. If quite a few people seem to click on it, they'll say, oh, this is a good thing. This must be something that people want to watch. So they show it more. They advertise it more. And even more people click on it. Well, it's still popular. Let's advertise it even more. That's what happened to Simon Dan with his gate video. The more people that saw it and decided, or saw the advert for it, decided to watch it, the more popular YouTube thought it was, so they advertise it more and more. It becomes a rolling snowball, gathering speed. So that's what was happening with Flat Earth. Now, you may say that's because Flat Earth is very popular, or it may be that a lot of people wanted to laugh at it. No matter what, the point was, a lot of people were looking at it, and so YouTube were pushing it more and more and more. That's what stopped. They changed the algorithm so they're not pushing it, so that you can do your Flat Earth video and maybe it'll be a very popular one that get an awful lot of views, but YouTube aren't going to help push it. That's what they stopped doing. So they're not stopping you from producing a video, they're just not helping to push it big time.
Yes, I agree. Yes.
Okay, so I don't call that censorship.
there,
Oh, it must be frustrating
I
if
didn't
you
say it
think.
was censorship. I said it was favoritism here. And there's,
Okay, yeah.
yeah.
I'd say it's favoritism towards the scientific consensus, which I appreciate that you won't like if your view is one that's a differing view.
So,
Had they been saying, no, Kyle, you're doing a video on flat Earth, it's banned. You've done another video on flat Earth, you're off the channel. Then, yeah, I'd feel more uncomfortable about that. The fact they're not pushing your channel, I'm okay with that. If you do a good, in quotes, video, or perhaps a video that I think, hey, I can debunk that, or someone else decides, look, this Carl's done this video, isn't it funny? Let's all laugh at it. Whatever. If that happens, and then you end up get your channel growing and getting more views and subscribers and whatever, fair enough. But
so I agree that there's a difference between burning a book, which should be more akin to deleting their channel or removing it from YouTube. That'd be in line with burning a book. And then there's also hiding books. I'm not going to make this one as easy to find as I would another book. And so there's two different things there, and I can agree with that.
GPS, who I'm going to read this comment out because GPS was the one who had super chatted earlier about mirroring videos.
Okay.
He says Kyle holds all the comments on his videos and only lets ones through that are pro flat Earth. How is that different than what YouTube is doing to flat Earth? I mean, I don't know if that's the case.
I hold all of the comments on my thing because I want to channel people to my debate board. That's the whole thing. Is when people openly try to start debates going on in my comments section, then there's no point in going to the debate board. And so I'm trying to people to go over there, and that's the whole idea behind that. And I like to drop the trolls before they, yeah.
Well,
before they.
I mean, I understand you want to promote your debate board. You could put that with links in every video. You could put that with links and something in the description.
I do that.
Could,
I provide links to my debate board.
You could pin a comment to the top pointing people to the debate board. But you're probably, I'm going to help you here, Carl. You're probably missing a trick in that if you let people comment, the more commentary there is in your video, against your video, pro or anti, it shows more interest in your video, which actually helps the YouTube algorithm. So you could be cutting your own throat. But there's other ways to stop trolls. I mean, there's no problem with people disagreeing with one of my videos. I have no issue with that at all. But a troll who's just there for hate speech sort of thing, you can stop a lot of that by, you can hold comments with links for approval. So I couldn't put a video, put a link to some dodgy video that you'd find inappropriate. You could check, no, I'm not going to allow that. But this one, okay, that's saying the globe is the globe because I disagree, but I'll let that go through. And it does help foster discussion. And the more, if I post a comment and then someone posts an argumentative comment back to me, I get alerted. So perhaps I'll go back again to comment again against them. So you'll actually end up getting more views and more interest in your videos if you allow it.
I did a thing recently, a community post saying, talking to me is a privilege. If you want to be disrespectful, that privilege can be revoked. And so that often ends up being the case.
Well, you do have the right to revoke it. I have blocked some people. There's not many, but I have blocked some. I quite openly welcome and allow disagreement. And I don't even mind a bit of silly name calling, that's fine too. The ones I've blocked have been literal hate speech, whether it's racism and stuff like that, which I'm sure you wouldn't want either. So I have no problem with blocking someone doing stuff like that. Now, in the chat here, live chat, we've got, or had, Gary Y. Benga, and we had PJCnet. With both of those, they disagree with me. They're posting their views, their flat earth views, and other people are arguing back, and that's fine. It's not trolling, it's just having a discussion or an argument. No problem at all.
And so there's a difference between censorship and just organization, systematization.
Yes.
I'm totally okay. If you want to disagree with me, I really welcome it. That's the whole reason why my debate board exists, is so people can disagree with me. I just want them to disagree with me over here instead of over here. And that's the thing.
Obviously it's your YouTube channel, your debate board. Maybe though you could respond a bit and then say, "Hey, let's continue over there." But it's up to you. But the point was made anyway by sorry, it was a guy called GPS, wasn't it? Okay, right. Well, I think, Kyle, we've covered quite a lot, and I've tried to hold your feet to the fire a little more tonight.
I appreciate it. I think it's been a fun thing, and yeah, in the same manner, I kind of hope to see the same thing with you. And it's hard to argue about something that I have no idea what you disagree with me on. And so, yeah, if a closer examination of those videos would be really appreciated, and that way I can directly see what phrases I said, what statements I made that you directly disagree with, and that'd be appreciated.
Well, like I said, I had with regard to your parallel light one, I'd had a look through the video. I'll be honest, I didn't think I was going to do a response video, but I don't know how we ended up talking, and I said, well, hey, let's debate it. I'm happy to have a debate because we can take it a bit further, which we did. It wasn't literally just addressing exact points. I mean, other points, other videos of yours are ones that I feel more like directly addressing, you know. Also, this isn't a, hey, let's just debunk or try and debunk Kyle Adams' channel. I'll do other people and other things as well. Yeah. But I have enjoyed this too, Kyle, I'll be honest, I have. And maybe we can get something meatier for another one, you know.
Okay, yeah. Yeah, and again, a good opening phrase, and that way we can know exactly what the parameters are, and that way, you know, we just had parallel light. That was our opening phrase. And so if it's more specific, we can actually have parameters and say, okay, we're not talking about all the light from the sun, we're just talking about a little bit of light from the sun.
Kyle, sorry to interrupt, Kyle. You sent me, hold on, I'm just trying to find it. You sent me a link to that light from the sun is not parallel. Before that, you sent a link to your debate board. Someone's asked for the debate board link.
That was a mistake.
No, that's okay. But someone has asked for your debate board. So can I post that link as a link to your debate board?
Absolutely.
Okay, let's post that. So anyone who wants to get onto and join Kyle's debate board, there is the link on myroad.com. Go there, disagree, have discussion, have argument, but keep it nice. Is that fair enough, Kyle?
I really appreciate the ones that specifically point to specific things that I actually said. A lot of people like to jump on there and argue about things that I never even said at all. And it's just like, I think it's my biggest pet peeve right there. It's just, yeah. What are you arguing? They like to attach random boxes to random boxes. And that's, yeah.
Okay.
They like to invent straw men and totally misrepresent something I said. They argue about things I never said at all. And so, yeah. I really appreciate the ones that actually take, okay, Kyle, you specifically said this, and I disagree with this because of this, this, and this. And that's what I look for. That's what I really appreciate.
Okay, well, what I'm also going to do is I'll just, where are we?
I've got every single video I've ever made concerning the flat Earth on that debate board. So if I've said it in one of my videos, it's fair game.
Well, what I'm doing is I'm also putting a link to. I haven't got a link to. Actually, I have got a link to your channel because it's just here. I'll put a link to your channel as well as the debate board in the description. I think that's only fair as you've appeared on here. But talking about
I'm not sure if that was the one to actually join the debate board. That might have been the link to view it. Let me make sure you get the right.
Okay.
The right here. To the right link.
Okay, that's fine.
Okay, I'm sending that to you.
Oh, okay. So we'll try that again then.
There we go. That's everyone's to join the debate.
Oh gosh, it's a long link, isn't it? Right. So this is the correct link then. I'll pop that in. Yes, welcome on board. I saw it say.
I'll allow you to actually participate and not just view it.
All right, and I'll pop that in the description of the video as well. Yeah, what I was going to say, we talked right at the start about mirroring. Now, what's happened here? Well, what I would say, Carl, we never talked about it, and I don't think you've mirrored the times when you've been on here, but I regard it as if I do have someone on as a guest for a chat or a debate, then I'm quite happy for you to mirror this stream if you wish. I'm not asking you to, but saying if you wish, then do feel free to mirror it, because hey, it's 50% you, 50% me. I think that's only fair.
Yep. Thank you.
Welcome. Okay, right. Well, I'm going to thank you, Kyle, for joining us tonight. We've been going for about 2 hours 20. It's been
very civil, so I appreciate that.
Oh, I think it always will, Kyle. I mean, not being funny, I'm going to disagree with you. I'm going to think that some things you say are wrong or silly, but I see no reason not to be civil, as you've not been not civil with me. So it's all cool. So what I'm going to do is I'll give you the last words in a moment, and then I'll pop you into the live waiting room. There's probably about 8 people there, and you're welcome to stay and chat. You know the people on my channel are a nice bunch of people. Yes, they're going to disagree with you, but they're not going to be abusive. So do feel free. So any last words, Kyle?
Am I in trouble here?
No. And yes, any last words? I need a black cap on. You shall be hung by the neck until dead for your flat Earth beliefs. Hey, it's not a bad idea, though, is it? No. Any final words before I let you go? I suppose.
Thanks for having me, and yeah, hear me out. So
No,
look forward to next time, as always.
Yeah. Cool. All right. Well, thank you very much, Kyle. You take care, and I hope you and your family all stay well. Okay. Off to the waiting room with you then, sir. Bye-bye.
Bye.
And Kyle is gone. Well, I honestly did enjoy that. Of course, I disagreed with Kyle. We knew that that'd be the case, but it was civil. I did try to be more holding his feet to the fire, ready to disagree firmly if required. I knew that it would not be a dumpster fire. Kyle's not like that, and I'm not like that. I could be like that with the right person, but Kyle's not that person. I'm just going to disagree. As I said, I found it difficult to bring up the business with the video with his daughter, but I think he took it well, and we discussed it. I'm not against homeschooling. I think, though, with homeschooling, it's something that has to be done extremely carefully to make sure that the kids are taught properly, taught what they need to know, taught what they need to know in life, and to be able to get on with other people. But yeah, so I was honest. It made me feel uncomfortable. I've expressed my views. I'm not really going to do any more than that. Listen, it's been great. I will watch this stream back so I can actually watch the comments, because most of the time my screen was covered up, so I couldn't see all that many. Thank you very much, all of you, for taking part. I did see we had about 228 or plus even people at the peak, which is wonderful to see. Thank you for the super chats, the memberships, my patrons, and all of you, really. You're such a fine bunch of people, upstanding people. Tomorrow night, I might be doing this all over again, but slightly different. So keep an eye out. If it pans out, it will be with Bev Try Thinking, but it's with a twist. The way it's set up is we should both be on the same side about something. How long that will be before he brings up level is not horizontal, or whatever it is, or level is horizontal, I don't know, because I don't want to go there. So it'll be interesting. What's this? Please don't kill. Sarcastic barman, what are you doing? Shilling yourself, sir? How very dare you? How dare you, Mr. Barman, sir? You owe me a pint when I pop in. Anyway, thank you very much, all. Take care. Good night. Stay sensible.
Mr. Sensible, Mr. Sensible, bring me some cheese, and get me only the best if you please, best if you please. Here are some flowers, let me display them. Yea, Dr. Warner, you have gone all slay them. Mr. Sensible, Mr. Sensible, you are a man. Every subscriber is a faithful fan. Bring your logic and your cheese. Mr. Sensible, help us out, please. Mr. Sensible, Mr. Sensible, I needed proof of gravity, so I jump off the roof. It's hard enough, let me go further. Why was I ever such a darn flat earther? Mr. Sensible, Mr. Sensible, I'm such a clown. I am the laughing stock of the town. Bring your logic and your cheese. Mr. Sensible, help me out, please. Mr. Sensible, bring me a sphere, to which the waters of the oceans adhere, add explanations that let me be